Welcome learners. Today's topic is chlorine and compounds. We want to proceed previous subtopic, that is chemical properties of chlorine gas. Previously we left from reaction of chlorine with metals, that is the last one was iron. Now note that in place of iron we can also use aluminum chloride because it also sublimes on heating. Now today we want to look at the reaction of chlorine with non-metals. We want to look at two of them, phosphorus and hydrogen gas. Now A, reaction of chlorine with phosphorus. Now note that phosphorus have three types: red, yellow and white. Now white and yellow phosphorus should not be reacted with chlorine gas. Reason, they are highly flammable. And we look at now reaction of phosphorus, red phosphorus chlorine gas. Equations: phosphorus plus chlorine, phosphorus 5 chloride, that is in excess chlorine, then that is chemical equation becomes P4 solid plus chlorine Cl2 gas arrow phosphorus PCl5 solid gas. Good. Then to balance the equation you place 10 where there is chlorine gas and then place 4 where it is phosphorus 5 chloride. Now next is phosphorus plus chlorine limited, get phosphorus 3 chloride. Chemical equation P4 solids plus Cl2 gas arrow PCl3 gas. Balance the equation, place 6 where there is chlorine, then place 4 where there is phosphorus 3 chloride. Now observation made when red phosphorus is lowered in a gas of chlorine gas is white fumes are formed. Reason, phosphorus reacts with chlorine gas to form phosphorus 5 chloride and phosphorus 3 chloride, which is white fumes. B, reaction of chlorine gas with hydrogen gas. Points to note: now chlorine and hydrogen gas do not react at room temperature. Note 2, a mixture of hydrogen and chlorine gas reacts explosively when heated. Hence, to prevent explosion, small amounts of hydrogen gas through a jet should be burned in excess chlorine. The equation will be hydrogen plus chlorine gas arrow hydrogen chloride gas. Chemical equation H2 gas plus chlorine Cl2 gas hydrogen chloride HCl gas. Balance the equation, place 2 where there is hydrogen chloride gas. Now observation made when a jet of burning hydrogen is lowered in a gas of chlorine gas, you say white fumes are formed. Reason, hydrogen gas reacts with chlorine gas to form hydrogen chlorides, which is white fumes. Now next chemical property is displacement reaction. Now chlorine displaces less reactive halogens, e.g. bromine and iodine, from a solution of its salts. So the first thing, look at what happens when chlorine is bubbled through potassium bromide. Chemical equation: chlorine gas plus potassium bromide aqueous. Chlorine displaces bromine from there, get potassium chloride aqueous plus bromine molecule aqueous. Balance the equation, place 2 where there is potassium bromide and 2 where there is potassium chloride. Now observation made when chlorine is bubbled through potassium bromide solution. Color solution changes to orange. Reason, chlorine is more reactive than bromine, hence displaces it from a solution of its ions. Now B, what happens when chlorine is bubbled through potassium iodide solution? Now chemical equation is chlorine gas plus potassium iodide aqueous arrow potassium chloride aqueous plus iodine molecule aqueous. Balance the equation, 2 where there is potassium iodide, 2 where there is potassium chloride. Now observation made when chlorine is bubbled through potassium iodide solution. color solution changes to red-brown. Reason: chlorine is more reactive than iodine, hence displaces it from a solution of its own. Now, next chemical property is reaction of chlorine with alkalis. The product formed when chlorine reacts with alkalis depends on 1. Concentration of the solution, 2. Temperature of the solution. Example 1. Reaction of chlorine with cold dilute sodium hydroxide. Now, chlorine reacts with cold dilute sodium hydroxide to form sodium hypochlorite, also called sodium chloride 1, and sodium chloride, and then water. Chemical equation is chlorine gas plus sodium hydroxide aqueous, RO. Sodium hypochlorite is NaOCl aqueous plus sodium chloride NaCl aqueous plus water H2O liquid. Balance equation, place 2 where there is sodium hydroxide. Now, the sodium hypochlorite formed is a bleaching agent. This has a pale yellow color. Now, equation that shows the sodium hypochlorite is a bleaching agent will be as follows: NaOCl plus dye, RO, sunlight, will give you dye plus O, then plus sodium chloride aqueous. Now, example 2, reaction of chlorine gas with hot concentrated sodium hydroxide. Now, chlorine gas reacts with hot concentrated sodium hydroxide to form sodium chloride 5, sodium chloride, and water. The sodium chloride 5 formed is used as a weed killer. Now, chemical equation where the reaction takes place is chlorine gas aqueous plus sodium hydroxide aqueous, RO, sodium chloride 5 NaClO3 aqueous plus sodium chloride NaCl aqueous plus water liquid. Now, to balance the equation, place 3 with chlorine gas, place 6 with the sodium hydroxide, place 5 with the sodium chloride, then place 3 with this water. Now, example 3, reaction of chlorine gas with calcium hydroxide. Now, chlorine gas reacts with calcium hydroxide to form calcium chloride, calcium hypochlorite, and water. Calcium hypochlorite is referred as a bleaching powder. Chemical equation: chlorine gas plus calcium hydroxide Ca bracket OH 2 aqueous, RO, calcium chloride CaCl2 aqueous plus calcium hypochlorite CaOCl2 aqueous plus water. And to balance the equation, place 2 where there is chlorine gas, 2 where there is calcium hydroxide, and then 2 where there is water. Now, next chemical property is oxidizing property of chlorine gas. Look at here 2 examples. Example 1, reaction of chlorine with ammonia gas. Now, ammonia gas, in this case, are reducing agents. So, the general reaction that takes place is chlorine gas plus ammonia gives you ammonium chloride plus nitrogen gas. To balance the equation, place 3 where there is chlorine, 8 where there is ammonia, 6 where there is ammonium chloride. Now, observation made during this reaction is white fumes are formed. Reason: chlorine oxidizes ammonia to nitrogen while itself reduced to hydrogen chloride gas. The excess ammonia reacts with hydrogen chloride gas to form ammonium chloride, which is white fumes. Now, example 2 is reaction of chlorine with aqueous hydrogen sulfide. Now, the reaction is as follows: hydrogen sulfide plus chlorine gas gives you sulfur plus hydrogen chloride. Now, the chemical equation is H2S aqueous plus chlorine gas, arrow, sulfur solids plus HCl aqueous. Now, observation made when chlorine is bubbled through hydrogen sulfide solution. A yellow precipitate is formed. Reason: chlorine gas oxidizes sulfide ions to yellow sulfur while itself is reduced to hydrogen chlorides. Now, note that when you're told that what happens when chlorine gas is inverted of a gasture of hydrogen sulfide gas, you'd say yellow solid is deposited on the sides of the gasture. Reason will be chlorine gas oxidizes hydrogen sulfide gas to sulfur and itself reduced to hydrogen chloride gas. Now the last reaction, example 3, is reaction with the sodium sulfite. The chemical equation is chlorine plus sodium sulfite plus water, arrow, HCl aqueous plus sodium sulfate aqueous. Balance the equation, place 2 where there is hydrogen chloride. Now, observation made when chlorine gas is bubbled through sodium sulfide solution, followed by addition of 2 to 3 drops of acidified barium nitrate. A white precipitate is formed. Reason: in solution, chlorine oxidizes sulfite ion to sulfate ion, while itself reduced to hydrogen chloride. The formation of a white precipitate with acidified barium nitrate confirms the presence of sulfate ions.